let us look at the liquid solutions. Types of solution in the liquid. First one is aqueous solution, second one non-aqueous solution, third one true solution, fourth saturated solution, fifth unsaturated solution, sixth dilute or concentrated solution. Aqueous solution means here water is the solute. Example, you can take the salt solution, that is made up of salt and water. Non-aqueous solution means here water is not the solute. So you can state the example of sulfur and carbon disulfide. Third one is true solution. True solution is the one in which solute is completely dissolving in the solvent and they are not visible. Okay. For example, sugar solution. Then fourth one is saturated solution. So what is a saturated solution? A saturated solution is one at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving. Okay, so such kind of solution is called as a saturated solution. Then what about unsaturated solution? Unsaturated solution is a solution where the solute contained in a solution is less than the saturation level. Okay, so it is called as unsaturated solution. Okay, then the last one is dilute or concentrated solution. So what is dilute or concentrated solution? In the concentrated solution, it has large amount of solute dissolved in it, comparable to the dilute solution. In dilute solution, it has very little amount of solute dissolved in it. Suspension. Suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles are visible through the naked eyes and solids are dispersed in the liquids. So what are the properties of heterogeneous mixture? So here particles scatter a beam of light. Okay, until the suspension breaks down, particle keeps on scattering the beam of light which is passing through it and make its path visible. Solute particles settle down when a suspension is left undisturbed. Solute can be separated from the mixture by the process of filtration in the suspension. Okay, so these are some of the properties of suspension. This is the image of how the Tyndall effect is possible. Okay, so for this you need a torch and you need two beakers which contains pure water and a colloidal solution. So you need to on the torch and pass the beam of light through these beakers. Okay, what you can see that pure water cannot pass the beam through it. You can't. It is the light beam is not visible through the pure water. But if you pass the same light beam through the beaker of a colloidal solution, it scatters the light through it and so the light beam is visible. Concentration of a solution. How we are going to find out the concentration of a solution? Yes, to decide the type of solution we need to find its concentration. So we have three methods to find out the concentration of a solution. First method is mass by mass percentage of a solution, where you are going to take mass of a solute and mass of a solution and going to substitute in this formula, that is mass of a solute upon mass of a solution into 100. Second method is mass by volume percentage of a solution. Having obtained mass of solute and volume of solution, you are going to find it, okay, by substituting this in this particular formula. Then third one is volume by volume percentage of a solution. So here you are going to find out the volume of solute as well as volume of solution. Okay, and going to substitute in this formula, you are going to get the concentration of a solution, that is volume of solute upon volume of solution into 100. see some of the methods for separating the components of a mixture. So the methods are evaporation, centrifugation, separation, sublimation, chromatography and distillation. So the first method is evaporation, which is conducted in order to obtain dye from blue or black ink. So after processing this particular method, you are going to get ink. Okay, that is a mixture of dye in water. Second method is centrifugation. Okay, in the centrifugation method, we are going to separate small solid particles in a liquid. And third method is separation, which is done through a separating funnel. Fourth method is sublimation. So sublimation is used in order to separate the camphor and salt. Then we use chromatography. So it is used in order to separate dyes in black ink. Then distillation method is used for separating two immiscible liquids. Okay, earlier I said you even separation through separating funnel is also used to separate the two immiscible liquids. Okay, so these are the some of the methods for separating the components of a mixture. So let us see one by one. First one was about evaporation. So here the activity is conducted by taking a beaker with half filled water in it, and then you are using a watch glass on the mouth of the beaker, and you are putting few drops of ink on the watch glass. So now after heating the beaker for a while, evaporation process starts, and after stopping the heating process, okay, what you can observe is the result obtained from this particular evaporation is that mixture of a dye is found in water. So thus you can separate the volatile component from its non-volatile solute by the method of evaporation. So this was about evaporation. Then I said you about centrifugation. So this is used actually to separate cream from milk. Okay, so this is usually used in dairy, okay, for separating the milk and cream. Then third method was about separating the mixture of two immiscible liquids. So it was separation method, which is done in a separating funnel. So look at here, you can see the funnel here. So in this funnel you are going to put kerosene oil and water. Okay, you have to leave it for a while so that it gets separated in two different layers. Okay, and you have a stop cock, and you have to keep it unopened. The stop cock should be closed, tightly closed. Then after the two immiscible liquids have separated into two different layers, you are going to open the stop cock until the water level is empty and it reaches the kerosene oil here. Okay, so until the oil reaches the stop cock, you are going to open the stop cock, and you are going to close it once water is completely emptied. So you can get kerosene oil and there is no water in the particular funnel. Okay, so this is what the separating funnel method. Then what about the next one? Even distillation is performed to separate two immiscible liquids. Okay, so here pure liquid component is obtained through the distillation method, that is called as fractional distillation method. Okay, so here you can see the diagram of that, right? So these were some of the methods that were used. And another thing, to separate the dyes in black ink using chromatography. What is chromatography? Chromatography is the process of separation of components of a mixture. Okay, so actually this technique was first used for separation of colors, so it is named as chromatography. So look at here how we are going to perform this. You need to take a thin strip of filter paper and you are going to draw a line on it using a pencil 3 cm above the lower edge. Put a small drop of ink on that particular line exactly at the center of that line. Then lower down the filter paper into a jar or glass or beaker or the test tube containing water. Okay, now you have to leave it undisturbed. So watch carefully what happens now. So water rises up on the filter paper. So at the end what happens is you can get the different shades, okay, different shades of the dye getting spreaded on the thin strip of filter paper. Okay, so the applications of chromatography is to separate colors in a dye, to separate pigments from natural colors, and drugs from blood. Okay, then so these are some of the methods, but you have so many other methods to perform the separation of components from a mixture. Okay, thank you. How can we obtain different gases from air? So air is a homogeneous mixture. Okay, so here how we are going to separate homogeneous mixture? So it is possible through fractional distillation method. So we have a flow diagram here that shows the step by step of the process. In the firstly we have to take air as the input, and we are going to compress and cool the air by increasing the pressure and decreasing the temperature. Then in the second step you are going to get a liquid air. Air is converted into liquid air. Now you are going to allow the air to warm up slowly in fractional distillation column. Now after that gases get separated at different heights. So what are the gases that we have obtained here? We are going to get oxygen, argon and nitrogen. So boiling point of oxygen is minus 183. So that means oxygen is obtained at minus 183 degrees Celsius boiling point. Argon is obtained at minus 186 degrees Celsius and nitrogen is obtained at minus 196 degrees Celsius of boiling point. So what are the percentage of air that we have obtained? Oxygen is about 20.9%, argon is about 0.9%, and nitrogen is about 78.1%. Okay, so this was the flow diagram that shows the process of obtaining gases from air. Okay, so if we want oxygen gas from the air, we have to separate out all the other gases present in the air. So therefore the air is compressed by increasing the pressure and it is then cooled by decreasing the temperature to get the liquid air. Okay, I think this was very much clear. So this is what the block diagram of separation of components of air. So here air is taken as input, then air is pressurized. Okay, that is you are going to get the liquid air here, and after that, after getting the cold compressed air, it is going to be separated out. Okay, then liquid air is obtained, and through which you are going to separate it into the liquid oxygen, nitrogen and argon.